Hello friends, let's look into another question on 2D motion. Let's say a person covered a distance of 20 meters at an angle of 30 degrees with respect to the horizontal, and then or I can say 20 meters at an angle of 30 degrees north of east, and then he took a turn and started walking. He covered 30 meters at an angle of 60 degrees. I will call it as west of north. Find, this was delta d1 and this was delta d2. Find the net displacement. Of the person. So how are we going to draw it on the navigation system? First of all, I'm gonna put it at a side so that I can draw. Now the person has covered 20 meters at an angle of 20 degrees north of 30 degrees north of east, and then I wanted to show the displacement d2. Then he covered 30 meters at 60 degrees west of north. So I'm going to draw a navigation system again at the end of the vector 1. So again, this is north, this is east, this is west, this is west, this is south. So then he covered 30 meters west of north. So he covered the distance somewhere here. West of north is this is 60 degrees angle. And if I wanted to represent it with respect to the horizontal, this angle, if I wanted to represent with respect to horizontal axis, this angle becomes 30 degrees. All right. So this is the information given to me. I wanted to find the net displacement. So net displacement means he will be somewhere here from the origin point, somewhere here. That's what I wanted to find. And this is 30 meters. How can I solve this question? So first of all, what I'm going to do, I'm going to draw the d1 vector on the navigation system, which is 20 meters 30 degree north of east. And if I draw it, this is 20 meters at an angle of 30 degree north of east. Can I find d1 x? That value will be 20 cos of 30, which is equal to 17.3 meters, and delta d1y will be equal to 20 sine of 30, which will be 20 times 0.5, which comes out to be 10 meters. Again, how I figured out these values, I'm gonna talk about it one more time. This will be his vertical displacement and this will be his horizontal displacement, and applying the SOHCAHTOA, I can find these values. So this will be 20 cos 30 degrees, this will be 20 sine 30 degrees, and that's gonna give me the answer. So make sure your calculators are in degree modes. And I figured out these values. Now I'm gonna draw d2 on the navigation system. So d2 is 30 meters 60 degrees west of north. So this is the angle given to me. So what I like to do is, whenever angle is given to me is with respect to the vertical axis, I like to change it with respect to horizontal axis, because it makes my life very easy. How? I'll tell you. So whenever I'll change the angle with respect to the horizontal axis, I can always write the horizontal component with cosine. So I'm going to directly write it as 30, this is 30 meters, 30 cos of 30 degrees, and then this component I will write it as 30 sine of 30 degrees. This condition will only prevail when I am taking the angle with respect to the horizontal. Otherwise I had to write this component. If I would have taken this 60-degree angles, then I would have written this horizontal component as 30 sine of 60 degrees. This and this will give you same values. You can calculate it also. They will end up giving you the same value. So whatever way is more convenient to you, you can apply that method, and this will become 30 cos of 60 degrees. Anyhow, I'm gonna erase these two values. I'm gonna keep the values which makes my life easy. So this is 30 cos 30 is 25.9, and this value is 15. So I figured out these two components, so I'm going to write it as delta d 2x is equal to 25.9 meters, and delta d 2y is equal to 15 meters. So I figured out these two components also. Now I wanted to find the resultant displacement. So I have to remove this, so please be patient with me. All right, so let's go back and write these values. So this one was d1x was 17.3, d1y was 10 meters. Delta d1x was 17.3, delta d1y is 10 meters, and delta d2x is 25.9, delta d2y was 15 meters, and I figured out these two values. Now I'm gonna recheck my values one more time. Yeah, 25.9 and 15, that's correct. So I'm gonna find delta d net in x direction. That will be delta d1 plus delta d2. Here I missed one part, so I should have represented the direction also. This is in east direction, this is in the north direction, because it's a displacement, so I have to represent the directions also. d2x, this is in west direction, and this one is in north direction. So d2x is in west direction, so this is west. So I'm gonna write 17.3 east plus minus of, or I'll keep the sign positive right now, 25.9 west. Now because this is west, so west we consider it as negative, so this is positive value, east minus 25.9, that's gonna give me 17.3 minus 25.9, gonna give me negative 8.6 meters. And delta dy net is equal to, again, delta d1y plus delta d2y. This will give me 10 plus 15, which comes out to be, both are in north direction, so both are positive values, and the value will be 25 meters in north direction. So I'm going to draw these two values again on a navigation system. So I'm going to change the color. So this value will be, this is y component is 25, and x component is it is negative 8.6, so 8.6 west. So I can't draw it on the east direction, so I'm gonna erase this. Oops, it'll be a long battle for me now. Okay, it will be in this direction like this, 8.6. Now again repeating, make sure you don't draw the resultant by adding the tips of these two vectors. That will be wrong. This is not the resultant. So vectors and vector additions, so this is the origin point, this vector is pointing outwards, this vector is pointing outwards, the resultant will also point outward. And then I will, rather than writing 25 here, I'll represent 25 here. This is 25, this is 8.6. I'm going to apply the Pythagorean theorem. This becomes a right angle triangle. So this is delta D equal to 25 square plus 8.6 square, which will be 25 square plus 8.6 square, which is 698. This is delta D square, and delta D value will be 8. This is 698.96. delta D comes out to be square root of this 26.43, and this is the magnitude of the displacement. Now I wanted to find the angle also, so I'm going to write tangent theta is equal to, again, opposite upon adjacent, which comes out to be, opposite value is 25 divided by 8.6 tangent theta. One more time repeating, theta equal to tangent inverse 25 divided by 8.6. make sure you are putting these values in the bracket while filing it in the calculator, otherwise your calculator will give you the wrong value. So tangent inverse, second function tangent inverse 25 divided by 8.6, that will be theta equal to 71 degrees. So this angle comes out to be 71 degrees. So I can write my final value as, final value will be delta D equal to 26.43 at an angle of 71 degrees. It will be north of west. That will be my final answer. So hopefully you were able to understand how to solve the 2D vectors using the component method. Thanks for watching. Have a good day. Bye.